Very fine, good morning. Welcome you all to the new skill enhancement course, CS3491, Artificial Intelligence and Machine Learning Laboratory. So, the experiment number one, which will be titled as Implementation of Uninformed Search Algorithms. Uninformed search algorithms are normally termed as blind search algorithms, which directly follows the algorithm steps without need any additional information. This uninformed search algorithm, which has several algorithms, the two major algorithms are named as breadth first search BFS, depth first search DFS. So initially we start from breadth first search, the implementation of breadth first search algorithm in Python. So the uninformed search is a class of general purpose searching algorithm which normally operates on brute force way. So this such algorithm do not need any additional information about state or state space. So it directly traverses the tree. It directly traverses the tree. So which will be called as blind search algorithm. This algorithm which directly follow the traverse, directly follow the algorithm procedure. So this algorithm which also termed as blind searching algorithm. So the example. So implementation of breadth first search, the first example. So the simple graph. So in addition to that, we are taking three array. So the first array for visited link, second array for queue, third array for out. So how the breadth first search works? So we will see here. So step number one, we will take an it as A is a root. We will take A is a root node. So automatically, if A is a root node, the entry which will be taken place in visited So entry which is taken place in visited array as well as queue. So now initially A was selected, A was entered in visited as well as queue. So now you can pop the value. So initially you can read A, after that you can read the child of A, B and C. After that we can read the child of B, D and E. Then you can take child of C, F, F already read, so fine. So the final output was A initially which will be printed, after that B which will be printed, after that C which will be printed, after that D which will be printed, after that E which will be printed, at last F which will be printed. It's a theme of it's a traverse of breadth first search algorithm. So it takes breadthwise. So like this. So starts from the first. Initially, which will print the A as a root node. So A which enter in visited as well as Q. So step number one, if Q is not empty, if the initially A is in Q, so if the Q is not empty, if the Q is not empty, then we can pop the element of Q and move it to output. Pop the element of Q and move it to output. So now so the output which contains A, so which will be pop, Q is empty. So next stage, find the neighbor of A. Find the child node of A, the neighbor of A. So the neighbor of A are B and C. So you can enter B and C in visited as well as Q. Enter B and C in visited as well as Q. Then you can follow the same step again. Now you can pop the top element of Q for the first element of Q and move it to output directly. Please see here. Now you can pop B and then move it to output directly. Now what will happen? B which will be popped, B which will be printed in output directly. So the child of B, D and E, the D and E which will be entered in visited directly as well as Q directly. So D and E are printed in visited and Q2. So next stage. So now the next value which will be taken, that will be printed in visited as well as Q. Now the top of the Q, the first element of the Q, which is C. So C which will be popped and move it to next location. C which will be popped and C which will be moved into next location. Yes, that's fine. Now the C which will be moved. So the element of C is F. Element of C is F. So the next step, F which will be placed in visitor as well as Q. F which will be placed in visitor as well as Q. So F was changed in green color. That's fine. Now the output was A, B, C. Now you can move the last element D to F. Pop the first element of Q to F. So A, B, C, D. Yes. Now there is no child for D. So pop the next element to output. Yes. There is an element. F is placed, but F already available. So no need to push. So E which placed in output. Next, F which is placed in output, the Q is empty. If the Q is empty, then you can exit. This is what your final output. So this is what the first search was. Starts from A, then it's child B and C, then it's child D and E, then F. So this is the way breadth first search works. I hope it's clear. Now we will see a simple example for breadth first search in Python code 2. So the example 2. So the root node is 14. The 14 which will be taken as root. Now the root node is 14. Then 12 and 16 are child, and 13 and 11 are child of 12. Then 17 is the child of 16 as well as 13. So this is what a simple example was framed. Currently, initially, visited array is empty, Q is empty, output is also empty. Initially visited array, Q and output, all those things are empty. Now, the first stage, we will take as root node as 14. Initially, root node as 14. If root node is 14, then the first step, you can place the root node in visited as well as the Q. So 14 which will be entered in visited array as well as Q. So, next step, if Q is not empty, then you can pop that element, pop the first element of the Q and move it into output M. So 14 which will be moved here. 14 which will be moved here. So next stage, now fine. So 14 which will be taken, 14 which will move to output. So output which contain 14. So output which contains 14, then the next child of 14, the neighbor of 14, that is 12 and 16, which will be entered in visited array as well as Q. So 12 and 16 are entered in visited array and Q. So next stage, so 12 and 16 are entered in visited array and Q. Now Q is not empty, so the loop was continued. So 12 which will be the first element of the Q which will be popped and move it into output M. The first element of the Q was popped and moved into output M. So now 12 was moved into output M. So the 12, the child of 12, the neighbor of 12, that is 11 and 13, which will be moved into visited array as well as Q. So 12, 11 and 13 which will be moved into visited array and Q. So visited array which contains 11 and 13, Q also contains 16, 11 and 13. Now the Q is not empty. Again the loop was continued. Q is not empty. So 16 which will be moved into M. 16 which will be moved into M. Okay, fine. Now 16 entered into M. The neighbor of 16 which entered into visited array as well as Q. 16 which entered into M. Then the neighbor of visited array which will be entered in visited as well as Q. So 17 which will be taken. 17 which will be placed in visited array and Q. Now Q is not empty. So 11 which moved into here. There is no child for 11. So there is no need. Now Q is not empty. So 13 which will be moved to here. 13. 13 also already, there is a child 17, but 17 already taken. So no need. So now 17. So 17 which will be found. Now Q is empty. So the traversal output is initially which take 14, next which will take 12, next which will take 16, next which will take 11, next which will take 30, next which will take 70. This is a traverse procedure. This is what breadth first search was. The same procedure which will be implemented in Python code. Please see here. So step number one, the first Python code, the step number one, you can create a graph. So graph, which is like a dictionary, you can take graph is like a dictionary, which is a key value pair. So the root node, which is a key, 14 is a key. The values of their child, 12 and 16. It's specified in array. Then the key is 12, its child is 11 and 30. The key is 16, the child is 17. So based on the graph, you can create a simple Python code. The key is 11, the array is empty. Key is 30, then the array which contains 17. The key is 17, then the array contains empty. So this graph, it should be converted into simple dictionary of Python. Next step. I can create a two array. One is a visited array. So visited array which is equal to empty. The second array is Q. Q is also empty. First array is visited array which is also empty. Second array is Q. Q is also empty. Now I will create a simple breadth first search function which contains three parameters. One is a visited array. The second parameter is the graph array. Third parameter graph dictionary. Third parameter is a root node. Third parameter is a root node. Initially, the root node, you can append visited array of root node. Then visited array. So the root node which will be entered in both visited array as well as Q array. After that, while loop which will be till the end of Q is empty, while loop which will be continued. The first element of the Q, that is pop 0. So first element of the Q which will be taken into output M. Print the output M. After printing the output M, you can find the neighbor of graph M. So the M value, its neighbor was found. If neighbor was found, you can append the neighbor in visited array as well as Q, then the entire loop was continued. So you can print the breadth first search traverse, you can call the algorithm BFS. Visited array is empty, graph is empty, the root node is 16. Sorry, root node is 14. The root node is 14. So here you can pass root node as 14. Next. So I will explain the algorithm again. So visited array is empty. Okay, visited array is empty. Q is empty. Okay, Q is also empty. Initially you can append visited array dot append of root node. So 14 was appended. Q dot append of 14. So root node is 14. So 14 was appended. Why Q? Q is not empty as Q contains 14. So Q is not empty. Then M equal to Q dot pop of 0. So 14 which will be moved from Q to M. So green color is M. Green color is M. Violet color is visited. Blue color is Q. Okay. So now which will be moved to Q. Okay, 14 which will be moved to Q. So now Q is empty. So for loop, finding the neighbor of the 14. So neighbor of the 14 is 12 and 16. Neighbor of the 14 is 12 and 16. Both the thing which will be entered in visited array as well as Q. Again loop was continued, while loop. Again while loop was continued. Then you can move 12 into M. You can move 12 into M. Pop the first element. Then find the neighbor. 11 and 13. Find the neighbor 11 and 13. That will be appended in visited array as well as Q. Then again continue. Then neighbor of you can push 16 into M. Then neighbor of 16 is 17. 17 was pushed. Then again 11. Again 13. At last 17. So the same loop was executed. At last we printed the final result as the traverse value, that is 14, 12, 16, 11, 13 and 17. This is what the Python code works. So this is a simple example implementation of breadth first search using Python. So same Colab code, the link is available in description. You can use that. Thanks for watching. Thank you all.